Hey guys, in this lesson we would discuss different applications of laws of exponents. The problems related to laws of exponents could be as simple as writing in single power. For example, if the question wants to write this in the form of a single power, all that we have to do is we just have to see what's the base. The base is same. There is no relationship between these two bases. No relationship seen means it's a multiplication sign in between the numbers. So the first number has power 2 times the second number has power 1. Result will be 5 to the power of 2 plus 1, which is 3. Another example could be to write this as a single power. So we see these two bases have no sign in between, means it's a multiplication sign. This one is underneath it, base is still same, so the relationship between these two and this is division. Therefore, no power here means power is 1. The rule says if the bases are same and there is multiplication, we add the powers. And if the bases are same and there is division, that's how it looks like, then we subtract the powers. So we would do 1 plus 6 minus 5. That gives us 6 plus 1 is 7 minus 5 is 2. So if the question wants us to write it as a single power, we will leave it like this. Or the question can ask us to simplify it. Then also we will leave it here. But if the question wants us to evaluate, means find the value of this, then we know 3 square can be written as 3 times 3, which is equal to 9. Let's take another example. We have two same bases. They are getting divided. Powers are different. So we would subtract the powers, 2 minus 4. And there is also a power outside on this entire thing, that is a minus 1. So when we simplify, 2 minus 4 is a negative 2. And there is a power negative 1. When there is more than one power on the base, then we multiply the powers. So we get 7 to the power of negative 2 times negative 1, which is equal to 7 to the power of 2. Another question where we have integer powers. So here the base is negative 3, which is same for both, up and down. We subtract the powers, so we put negative 2 minus negative 5. We get negative 2 minus and minus is a plus 5. We get negative 2 to the power of 3. We notice here that the laws of exponents stay the same. No matter the power is an integer power or the power is a whole number power. When there is division, we subtract the powers. When there is multiplication, we add the powers. These are all simple questions. Questions could be complicated as well. Let's take a few examples for some complex problems. The question wants us to simplify and express answers with positive exponents. Always remember the final answer should be with the positive exponent, no matter they ask or they don't ask in the question. And the first example we have is negative 2x to the power of 5 whole thing has a power 3 over 8x to the power of 10. Here we have to notice one thing, that this power 3 is on the entire bracket. So this power 3 is on both the number as well as the variable. When we have two terms inside the bracket, or when we have a number and the variable inside the bracket, and there is a power outside the bracket, and that power has to be placed on each of the number and the bracket. So we can rewrite the question as negative 2 to the power of 3 times, we can put times with this dot, because if you put with the multiplication sign, it might confuse with this x to the power of 5. Now x has two powers. It has a power of 5 and it also has a power of 3. Whenever any base has two powers, they get multiplied. So we can multiply 5 and 3. Then we have 8x to the power of 10. We can write this negative 2 to the power 3 as a negative 8. X to the power of 5 times 3 is 15. Then denominator we have 8. This is also no operation seen in between 8 and x, so that means it's multiplication, times x to the power of 10. Now this question is a combination of constant and variable. So what are we going to do is we're going to separate the constants and variables. So the constant is 8, negative 8 over 8, and the variable is x to the power 15 over x to the power of 10. Negative 8 divided by 8 is a negative 1. X is same base, both numerator and denominator. Powers are different, so we will subtract the powers because they're getting divided. And the final result that we get is negative 1 x to the power of 5. And we make sure that the final exponent is a positive power, and this is a positive power, so we need not change this anyways. Let's take up another example. If we have n to the power of negative 4 times n to the power of negative 6, whole thing has a power -2 over n to the power -2 times 7. How do we do this type of question? We first notice that this has only variable and the variable is n. However, the first step is to individualize the power. That means this power -2 is on the whole bracket, which has two different things inside the bracket. So first we would have to bring this power on each of the terms inside the bracket. So we can write it like this, -4 times -2, because n has a power -4, n has a power -2. More than one power means we multiply the powers, multiplied by, because these two n's are being multiplied with each other. So we have n to the power of -6 times -2 over n to the power of, here also n has two powers, so we multiply -2 times 7. Finally, we get n to the power of -4 times -2 is an 8 times n to the power -6 times -2 is 12. And on the denominator, we have n to the power of -2 times 7 is a -14. Now we notice it's only one base, that is n, and the base is same. So we would just follow the laws of exponents. When it's multiplication, we'll add the power. So we would do 8 plus 12 over n to the power of -14 can be written as n to the power of 8 plus 12 minus -14. And that gives us n to the power of 8 plus 12 plus 14. That gives us n to the power of 26 plus 8, which is 34. And we see that the final answer has a positive power. So this is the final answer. Another example of a complex problem could be 4r to the power -6 times -2r squared. Whole thing has a power of 5 over -2r whole thing has a power of 4. Now here this -6 is just the power on r, whereas in this case this 5 is a power on this entire bracket. So the first step is to individualize the power. Here we can write on 4 times r to the power -6, and in this case we can bring this power on both r as well as 2. So we can write it as -2 to the power of 5 times r to the power of 2 times 5 over, here also power of 4 is on the entire bracket, so -2 to the power of 4 times r to the power of 4. Now to solve this, we can bring all the constants together because there are two different terms. One is a constant and one is the variable r. So we can bring the constants on one side and we can bring the variables on the other side. So 4 times -2 to the power of 5 over -2 to the power of 4 can be brought together, times r to the power of -6 times, this is r to the power of 2 times 5. So this is multiplication, not point. 2 times 5 is 10 over r to the power of 4. This will make our life easier when we are solving complex exponent problems that have both variables and constants and has multiple different laws applicable to it. Once we separate this out, we know these two bases are same, -2 and -2. So we can apply law of exponent here. We can write it as -2 to the power of 5 minus 4 because these two are getting divided. Here we can apply the laws of exponents because we have the same base r here. So r to the power of -6 plus 10 minus 4, and the result that we get is 4 times -2 to the power of 1 times r to the power of -6 plus 10 is a 4 minus 4 is a 0. -2 to the power of 1 is -2, so 4 times -2, and any number raised to the power 0 is 1. When we multiply 4 with a -2, we get a -8 multiplied by 1 is a -8 itself, and that's our final answer. Let's do one last question for the sake of practice. Here we have many terms inside the bracket, so there is 2a, b, c, where we notice that 3 is just as a power written on c. There is no power inside on b, a, or 2, but there is a whole power outside, that is -2. This power is applicable to both numerator as well as denominator. So we would first individualize this power, but before doing that, we notice that the denominator 2a squared b cubed c has a whole power of 2 as well. This is the first thing to individualize. So we would get 2abc cubed. We are not touching the numerator yet, but we are bringing this 2 on each of these terms. So 2 to the power of 2 times a squared times 2 times b to the power of 3 times 2 times c to the power of 2 this whole thing has a power -2. Now we can simplify the inside of the bracket. So we have 2abc cubed. We can write this down as 2 to the power of 2 times a to the power of 2 times 2 is 4 times b to the power of 6 times c to the power of 2. Whole thing is a -2. Now this -2 is going to be brought on each of these terms inside the bracket, because this -2 is both applicable on the numerator and denominator. So this is going to be brought as a power on each of the numerator and denominator terms. And how is this going to be done is 2 to the power of -2 times a to the power of -2 times b to the power of -2 times c to the power of 3 times -2 over 2 to the power of 2 times -2 times a to the power of 4 times -2, b to the power of 6 times -2, c to the power of 2 times -2. We can simplify this, and this gives us 2 to the power of -2. Now we can collect all the like terms, so 2 together. Here we have 2 to the power of -4. We can write down a's together, a to the power of -2 over a to the power of -8. 4 times -2, then b to the power of -2 over b to the power of -12, then c to the power of -6 over c to the power of -4. So here we would have as bases 2 powers are supposed to be subtracted because they're getting divided. So -2 minus -4. Here we have a to the power of -2 minus -8. Then we have b to the power of -2 minus -12. C to the power of -6 minus -4. This would give us 2 to the power of -2 minus and minus is plus. So -2 plus 4 is a 2. -2 plus 8 is a 6. -2 plus 12 is a 10. Then -6 plus 4 is a -2. Finally, we can write down 2 to the power 2 as 4, a to the power of 6, b to the power of 10. Now this c has a power -2 because we want finally all the powers to be positive. So c will go underneath with a positive power. And this is how we finally leave our answer.